How to match input impedance for ADC conversion. If you have ever wondered how to ensure your analog to digital converter functions at its best, you are in the right place. Matching input impedance is a key step in this process. Let's break it down into simple steps and concepts. First, what is input impedance? It is the resistance that the analog to digital converter sees when a signal is connected to its input. This impedance can vary based on whether the converter is buffered or unbuffered. Buffered converters maintain a steady impedance across different frequencies. On the other hand, unbuffered converters, like switch capacitor types, have changing impedance due to their switching behavior. Now, why is impedance matching so important? The main goal is to make sure that the source connected to the converter sees only a real resistance at the frequency of the signal. This prevents any reflections and ensures that the maximum power is transferred from the source to the converter. To start matching the input impedance, you first need to determine the input impedance of your analog to digital converter. For unbuffered converters, focus on the impedance during the track mode, which is when the converter samples the input signal. You can usually find this information in the converter's datasheet. Next, you will want to choose a matching technique. There are several methods available. One common approach is to use resistive networks. Another option is to incorporate inductive components, such as coils or ferrite beads. Transformer-based circuits are also popular, especially in radio frequency applications, as they can convert single-ended signals to differential while minimizing noise. For narrowband applications, you might consider resonant matching. This technique involves adding components that resonate out unwanted capacitances, ensuring a precise match at specific frequencies. When designing your matching circuit, you will use various components. Capacitors are often included for direct current blocking or as part of a resonant circuit. Inductors or ferrite beads can help in resonating out capacitances or achieving impedance matching. Resistors can be used for back termination to manage standing waves when there is an imperfect match. In practical applications, especially at high frequencies, impedance matching becomes even more critical. It helps prevent signal reflections and distortion. In these cases, transformer-based matching circuits are often the go-to solution. If your source cannot adequately drive the analog to digital converter due to an impedance mismatch, you may need to add signal conditioning stages. This ensures the signal levels are appropriate for conversion. Lastly, consider the type of signals you are working with. Differential signals, which are balanced, are less prone to noise and can be matched more effectively using balance or transformers. Matching the input impedance of an analog to digital converter is all about understanding its input characteristics, selecting the right technique, and designing a circuit that optimizes signal transfer while minimizing distortion. This is essential for achieving accurate conversions, especially in high-frequency settings.